You know how you can type a sentence into a machine and it just knows how you feel? It can tell if you're happy or angry or maybe even a little sarcastic. So, have you ever wondered how it actually does that? Well, today we're going to crack that code. We're going right inside the AI's black box to see exactly how it figures out human sentiment.
Okay, so where does it all begin? Well, from the outside, it looks almost ridiculously simple. You, as the user, might just write a couple of lines of code. You're just feeding a sentence into something called a pipeline.
And boom, just like that, you get this perfectly clean, easy-to-understand answer back. It tells you the sentiment is positive, and it's even super confident about it. I mean, it really does feel like magic, right? Like the machine just gets it.
But how? I mean, really, how does that work? How does the machine take a bunch of letters, just raw text, and come up with a final judgment call like positive? Well, that's the big question we're going to tackle right now.
All right, let's dive in. It turns out it's not magic at all. It's actually a really elegant logical process. Think of it as a three-step journey from our words to the machine's understanding. And we're about to break it all down piece by piece. First up, step 1, from text to tensors. This whole stage is basically about translation. We've got to get our human language ready for the machine to even look at it. And the star of this first step? It's something called the tokenizer. Honestly, the best way to think of it is like the AI's own universal translator. Its whole job is to take our messy, complicated human language and turn it into the one and only thing a model actually understands: numbers. Now, this translation isn't just one simple action. It's more like a precise three-part recipe. First, the tokenizer chops up our sentence into smaller bits called tokens. Next, it looks up each token in its massive dictionary and gives it a unique ID number. And finally, it tacks on any special tokens the model needs to make sense of where the sentence starts and stops. And here's what that looks like in practice. You can see two totally different sentences, one full of excitement and the other not so much. And both are now just lists of numbers. See how they both start with 101 and end with 102? Those are those special markers I was talking about. They're like little flags telling the model, hey, the sentence starts here, and okay, we're done here. But we're not quite done with the translation. A simple list of numbers is good, but to get maximum speed, especially on hardware like GPUs, we need to package it up. So this list gets converted into a special format called a tensor. Just think of it as the perfectly optimized container that the AI's brain is designed to work with. Okay, step 2. Now we get to the really cool part, the model's brain. Our text is translated, it's packaged up in a tensor, and now it's time to see where the real thinking happens. All right, so here's the super important point. You need the right tool for the job. A general-purpose base model is like a brilliant researcher. It can read our text and generate something called hidden states, which is just a fancy way of saying it has a really deep, contextual understanding of what was said. But for our specific job, we don't need a research paper, we need an answer. So we use a specialized model that has a classification head bolted on. That part is designed to do one thing: give us scores for positive and negative. And when I say this understanding is deep, I'm not kidding. For every single one of those little tokens we made, the base model creates a huge vector of numbers. So it's not just looking at the word waiting and saying that's a verb. No, it's capturing everything about what that word means in this exact sentence. Just how massive are we talking? Well, this number kind of says it all. For a pretty standard model, that vector has 768 dimensions. That means 768 different numbers are used to describe the meaning of just one piece of our sentence. That is an incredible amount of information, and it's what lets the model understand all the tiny nuances in our language. But look, for our task, we don't need a 768-point essay on meaning. We just need a simple yes or no, positive or negative. And that's exactly what that classification head does. It takes that giant, super complex understanding and boils it all down to just two simple numbers: one score for negative and one for positive. And this is what we get out. Those full sentences, full of human emotion, have now been crunched down into these two little pairs of numbers. But what are they? They're clearly not percentages, so we're not at the final answer just yet.
Which brings us to our final step, the home stretch, from numbers to meaning. We've got the model's raw scores, and now we just need to translate them back into something a human can actually use.
So back to that question, what are these numbers? This is something that trips a lot of people up. They're not probabilities, they're what we call logits.
So what's a logit? It's basically the raw, unfiltered score that pops out of the model's last layer. You can think of it as the model's raw confidence level. A bigger number means more confidence in that answer, but they aren't on a nice, clean scale from 0 to 100, so they're not super useful to us yet.
So, to get them into a format we can actually understand, we do one last little bit of math. We take those raw logits and run them through a function called SoftMax. All SoftMax does is take any bunch of numbers and neatly convert them into probabilities that all add up to a perfect 100%.
And just look at that transformation. The raw, kind of weird logits on the left are now clean, simple probabilities on the right. Our first sentence, a 96% probability of being positive. The second, a whopping 99% probability of being negative. Now that is an answer we can work with.
So here's the final verdict. We just matched the highest probability to its label. Sentence 1 is overwhelmingly positive, and sentence 2 is just about as negative as you can get. The loop is officially closed.
So there you have it. We've gone all the way from what felt like some kind of tech magic to a clear, step-by-step mechanical process.
That magic we started with, it's really just this elegant 3-step pipeline. Step 1, tokenize the text into numbers. Step 2, feed those numbers to a model to get raw scores. And Step 3, decode those scores back into a human-readable answer. That's it. That's the whole trick.
So now you've seen behind the curtain. The magic isn't magic at all, it's just a logical, repeatable process. And now that you know how it works, the real question is, what are you going to do with it? Because the best way to really understand this stuff is to jump in, get your hands dirty, and build something yourself.